All right, so we're diving into some seriously cool stuff today. We got a request to dig into Professor Ramesh Dungana's Chapter 7 Planetary System.
Ah, yes, a fascinating chapter indeed, full of cosmic insights.
Seems our listener is super curious about how our solar system, actually came to be,
Mm,
and who can blame them. It's a pretty mind-blowing story, right?
absolutely. And this chapter really breaks it down in a very understandable way.
So where do we even begin with something as massive as, well, the entire solar system?
Well, it all starts with a cloud, believe it or not.
A cloud, like the ones we see in the sky.
Not quite. Think bigger, much bigger. We're talking about a nebula, a gigantic cloud of gas and dust just hanging out in space.
Okay, I'm picturing like a giant cosmic dust bunny.
That's actually not a bad analogy, but this dust bunny is mostly hydrogen and helium, and it's the birthplace of, well, everything we know and love in our solar system.
That's incredible. So how does a cloud of dust become like planets and a sun and all that?
Well, gravity is the real star of the show. It starts pulling all that gas and dust together toward the center of the nebula.
Right. Gravity always bringing things together.
Exactly. And as it all gets pulled in, the cloud starts to spin, and it spins faster and faster as it shrinks.
It's like a figure skater pulling in their arms, right? They spin way faster.
Perfect analogy. So we've got this spinning cloud, and it eventually flattens out into this disc shape. And that, my friend, is where the magic really happens.
So are we talking planet formation already?
Yeah.
Or, hold on, gotta have a sun first, right? Can't have a solar system without a sun.
You're absolutely right. The sun comes first. At the very center of this swirling disk, all that gas and dust is getting super squished together, right? The pressure and heat build up to insane levels, like millions of degrees.
Sounds toasty.
You could say that. And at that point, nuclear fusion kicks in. Hydrogen atoms start fusing together, creating helium and releasing an unbelievable amount of energy. Boom, our sun is born.
Let's talk about a dramatic entrance. All right, so we've got a shining new sun. What about all the other stuff, the planets, the moons, all that? Do they just kind of poof into existence too?
Not quite poof, but they all come from that same disk of leftover gas and dust. It's all about collisions. Particles bump into each other, stick together, and form bigger and bigger clumps. And those we call planetesimals.
Planetesimals, kind of like the seeds of planets.
Exactly. But here's where things get even more interesting. The planets didn't all form in the same way. It all depended on their distance from the sun. Close to the sun, it's way too hot for the light stuff, like hydrogen and helium, to hang around.
You just get, like, blown away.
Essentially, yeah. So the inner planets, those closest to the sun, like Earth and Mars, they form mostly from heavier elements, creating those rocky, solid worlds.
Makes sense. So the inner solar system is where the rock and roll is. What about farther out?
Farther out, it's much cooler, and those lighter elements can finally stick around. That's where the gas giants come in. Jupiter, Saturn, Uranus, Neptune. They gobble up tons of hydrogen and helium, becoming these massive swirling worlds.
So they basically kept a lot of that original nebula stuff, huh? Like their own little piece of the early solar system.
Right, and that's why we call it a primary atmosphere. They captured it directly from the nebula.
But wait, Earth has an atmosphere too, right? And it's definitely not mostly hydrogen and helium.
You got it. Earth's atmosphere, and the ones on Venus and Mars too, they formed way later through a process called outgassing.
Outgassing sounds kind of unpleasant.
Well, it involves a lot of volcanoes spewing out gases from inside the planet. Plus, comets and asteroids probably chipped in, delivering things like water and other molecules. So yeah, a bit messy, but hey, it gave us air to breathe. And since these atmospheres formed later, we call them secondary atmospheres.
Secondary atmospheres, got it. It's amazing how different processes created such a variety of planets. But hold on, not every object in the solar system got to keep an atmosphere, right?
Right. Some objects, like Mercury or our own moon, their gravity just wasn't strong enough. The gases just kind of floated away, leaving them with these super thin atmospheres.
So size does matter in the solar system, at
Yeah.
least when it comes to holding on to an atmosphere.
Absolutely. It's all a delicate balance of gravity, composition, and distance from the sun.
And speaking of amazing things in our solar system,
Oh, I know where you're going with this. Professor Dingata throws in some seriously cool facts about our cosmic neighbors. Did you know Jupiter has this crazy storm, the Great Red Spot, that's bigger than Earth? It's been raging for centuries. Makes hurricanes here look like little dust devils.
it's truly mind-boggling. And the cloud patterns on Jupiter and Saturn, they're always shifting, changing colors, making these incredible dynamic displays.
Like a cosmic light show. Exactly. And then there are Saturn's rings, of course. Millions of icy particles just orbiting the planet, creating this breathtaking spectacle. You can't help but be awestruck by them.
Oh, definitely. I remember seeing pictures of them for the first time and being totally blown away. And speaking of mind-blowing, Professor Dungana mentions that there's evidence liquid water once flowed on Mars. And there might even be underground aquifers there today, hidden reservoirs of water.
Yeah, it's a pretty amazing thought. And it makes you wonder, right? If there was water, could there have been life too? Maybe even still is. I mean, this chapter really makes you realize there's so much more to discover, even right here in our own solar system.
Absolutely. It's like we've barely scratched the surface. But hold on, how do we even know how far away all this stuff is? I mean, we can't exactly grab a tape measure and stretch it to Jupiter, right?
You're right. We need a different kind of yardstick for cosmic distances, and that's where the Venus transit method comes in.
Okay, the Venus transit method. Sounds intriguing. How does that work?
So imagine you're looking at the sun, and you see this tiny black dot moving across it.
A black dot, like a little blemish on the sun.
In a way, yeah. But that dot is actually Venus passing directly between the sun and Earth. And by observing this transit from different locations here on Earth and using some clever math, we can actually figure out the distance between us and the sun.
Wow, so we're basically using Venus as a marker to measure the solar system. Pretty ingenious.
It is. And once we know that distance, we call it the astronomical unit, or AU, we can use it to measure distances to other planets and objects. It's like the foundation for understanding the scale of everything out there.
So the Venus transit method gave us our cosmic ruler. But wait, knowing the distance is one thing. How do we actually get up close and personal with these celestial objects?
Well, that's where space exploration comes in. And we've got a whole toolbox of ways to explore, from flybys to orbiters to landers. It's like a cosmic buffet of options.
A cosmic buffet like that. So what's on the menu? What are the different ways we can explore?
Well, we've got flybys, where a spacecraft zips past a planet, snapping pictures and gathering data as it goes. It's a quick peek, but it can reveal a lot.
Like a tourist snapping photos on a drive-by.
Exactly. Then there are orbiters. These spacecraft actually circle a planet for longer periods, allowing us to get more detailed observations and maps.
So more like settling in and really getting to know the neighborhood.
Exactly. And then for the truly adventurous, we have probes and landers. These brave little explorers actually touch down on the surface, giving us that up-close and personal perspective.
Wow. Sending a lander to another planet. That must be incredibly challenging. I mean, just landing safely is a huge accomplishment. But then they have to operate in these extreme environments, collect data, and send it all the way back to Earth.
Right. It's truly remarkable what we've been able to achieve. And we've had some incredible missions that really stand out. Like, take the Voyager spacecraft. They did flybys of all 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. Sent back some truly stunning images and invaluable data about those distant worlds.
Voyager.
Yeah.
That's the one that's, like, left the solar system, right? It's out there in interstellar space.
That's right. A true pioneer. And then there was the Galileo mission, which orbited Jupiter and studied its moons in detail.
Oh, and what about those Mars rovers? The ones that are driving around on the surface looking for signs of past life?
Yeah, those are incredible feats of engineering. They've been sending back amazing images and data about the Martian environment.
It's so cool that we can explore other planets like that. But wouldn't it be even cooler to bring pieces of them back to Earth? Like, imagine holding a piece of Mars in your hand.
That's the dream, right? Sample return missions are the holy grail of planetary exploration. Imagine analyzing the rocks, the minerals, maybe even finding evidence of past life. The possibilities are just mind-blowing.
And to think, it all started with a giant cloud of gas and dust.
It just goes to show sometimes the most amazing things come from the most unexpected beginnings. You know, when you think about it, it really makes you wonder, are we alone in the universe?
Right. I mean, that's like the biggest question of all.
And with all these new discoveries like exoplanets and the potential for life on other worlds, well, it doesn't seem so far-fetched anymore.
Yeah, it's kind of mind-blowing to think about. I mean, this whole deep dive has really gotten me thinking about the possibilities. Like, is there another Earth out there somewhere with, oceans and mountains and maybe even aliens walking around?
It's definitely a possibility. I mean, statistically speaking, the odds are in favor of there being other planets out there with conditions similar to Earth. We've already discovered thousands of planets orbiting other stars, and we're just getting started.
Thousands. Wow. So are we talking like potential alien civilizations out there, or are we thinking more along the lines of, microbes and bacteria?
Well, it's probably more realistic to expect microbial life at first. But even finding that would be absolutely groundbreaking. It would mean that life isn't unique to Earth. And who knows, maybe some of those microbes evolved into something more complex over billions of years.
Right, like alien dinosaurs.
Yeah.
Okay, maybe not dinosaurs, but I get your point. It's all about the potential, right?
Hmm.
And speaking of potential, what about those missions to Mars and those icy moons we were talking about, Europa and Enceladus, right? Are those all about searching for alien life too?
Absolutely. Those are prime candidates for finding signs of past or present life, even if it's just microbial. Think about it. Europa, one of Jupiter's moons, it's got this massive ocean beneath its icy surface. An ocean that might be even bigger than all the oceans on Earth combined.
Oh, an ocean under the ice. How is that even possible?
It sounds crazy, right? But thanks to observations from spacecraft like Galileo, we've seen evidence of this salty liquid water ocean hidden beneath Europa's icy shell. And what's really exciting is that there might be hydrothermal vents down there.
Hydrothermal vents, those are like underwater geysers, right?
Yeah.
I remember reading about them in the deep ocean here on Earth. They're teeming with life, even in those extreme conditions.
Exactly. And if they exist on Europa, well, they could provide the energy and nutrients needed for life to thrive.
So we could have alien life swimming around in an ocean under the ice on a moon of Jupiter. It's almost too much for my brain to handle. But okay, let's shift gears a bit. Professor Dungana also talks about how the planets formed, and he mentions that there are still some things we don't fully understand, like how did the gas giants get so big so fast? I mean, they're massive.
That's one of the big mysteries. They managed to accumulate huge amounts of material in a surprisingly short amount of time, astronomically speaking.
So it's like they went through a growth spurt on a cosmic scale.
You could say that. And there are subtle differences in their composition, which suggest that there might have been some variations in how they formed. So there's still a lot to learn about these gas giants.
It's pretty amazing to think that even with all our technology and scientific advancements, there's still so much we don't know. It's like the more we learn, the more we realize we have to learn.
Exactly. It's a constant journey of discovery, and that's what makes space exploration so exciting, right? There's always something new to learn, some new mystery to unravel. Like, take the formation of planets in general. The nebular hypothesis is a great model, but there are still some gaps in our knowledge.
Right. It's like a puzzle with some missing pieces.
Exactly. And we're constantly trying to find those missing pieces to refine our understanding of how our solar system and other planetary systems out there came to be. And speaking of other planetary systems, I mean, we've been talking about finding life in our solar system, but what about beyond? What are the chances of there being, another Earth out there with intelligent life?
Right, like a whole other civilization. That's some serious sci-fi stuff.
It is. But with all these exoplanets we're discovering, it's becoming more and more likely that we'll find another planet with conditions that could support life.
And we're actually able to find these exoplanets, even though they're like light years away.
We are. We've got some incredibly powerful telescopes, like the Kepler Space Telescope, that can detect these distant worlds, and some of them seem to be in the habitable zone of their stars.
Habitable zone, meaning they're the right distance from their star for liquid water to exist, right?
Well, exactly. Not too hot, not too cold, just right for life as we know it.
So how do we know if they have atmospheres? Or water? Or maybe even signs of life?
Well, that's where future missions like the James Webb Space Telescope come in. It'll be able to analyze the atmospheres of exoplanets, looking for telltale signs of things like oxygen or methane.
Wow, so we're going to be able to peek into the atmospheres of planets that are light years away. It's incredible how far we've come. But okay, let's bring it back to our own solar system for a moment. What about future missions closer to home? What's on the horizon?
Well, NASA is planning a mission to Europa, one of those icy moons we were talking about. It's going to specifically look for signs of life in that subsurface ocean.
So they're going to send a spacecraft all the way to Jupiter, land on Europa, and then drill through the ice to get to the ocean. That sounds ridiculously ambitious.
It is, but the potential payoff is huge. Imagine finding evidence of life in an entirely different world, with an ocean completely separate from our own. It would completely change our understanding of life itself.
Right. It would mean that life is probably much more common than we think.
Exactly. And, all this talk about life, it really makes you appreciate how precious it is and how fleeting. I mean, our sun isn't going to last forever, right?
Yeah, that's something I've always found kind of scary. Like, what happens when the sun dies?
Well, It's not going to happen for billions of years, but when it does, things are going to get pretty dramatic. The sun's going to expand, becoming what's called a red giant.
A red giant, so like a giant red sun.
Exactly. And as it expands, it's going to engulf Mercury and Venus.
Whoa. And what about Earth?
Well, it's possible that Earth could be swallowed up too. But even if it escapes that fate, things are going to get really hot here. Like, boil the oceans, make the planet uninhabitable hot.
So basically, game over for life on Earth. That's pretty depressing. And what about the other planets, the outer ones?
They'll get pushed further out into the solar system as the sun expands. Their orbits will be all messed up. It's going to be a completely different solar system than what we know today.
Wow. I never really thought about that. It's kind of unsettling to think that everything we know and love, everything we're working so hard to explore, is eventually just going to, disappear.
I know. It's a humbling thought. But it also makes you realize that we should cherish what we have while we have it. And it makes our efforts to understand the universe, to search for life, even more meaningful, don't you think?
Yeah, I guess so. It's like, even though our time is limited, we can still make the most of it by trying to unlock the secrets of the universe. And who knows, maybe by then we'll have figured out how to travel to other star systems to find new homes for humanity.
Now that's some optimistic thinking. But hey, anything's possible, right?
Yeah.
Yeah, who knows what the future holds? Maybe we'll be zipping around the galaxy like in Star Trek.
Well, one thing's for sure. This deep dive has really opened my eyes to the wonders of our solar system. And it's all thanks to Professor Dungana's amazing chapter.
He really does a great job of explaining these complex concepts in a way that's, easy to understand.
Yeah, I feel like I learned so much about how our solar system formed, about the different planets and moons, about the methods we use to explore space.
And those fascinating facts, like that storm on Jupiter, the Great Red Spot, it's incredible to think about. And those rings around Saturn. I mean, come on, they're just breathtaking.
Totally. And then the possibility of life on other worlds, it's just mind-blowing.
It really makes you realize that we're part of something much bigger than ourselves.
Exactly. It's like we're just a tiny little speck in this vast, incredible universe.
Yeah.
And yet here we are exploring it, trying to understand it, searching for answers to some of the biggest questions of all time.
And that's what makes it so exciting, right? The constant pursuit of knowledge, the never-ending quest to unravel the mysteries of the cosmos.
It's like the universe is this giant puzzle, and we're slowly but surely putting the pieces together.
And every new discovery, every new mission, every new piece of data brings us closer to understanding our place in the universe.
You know what really struck me from Professor Dungana's chapter was this sense of interconnectedness, like how the remnants of ancient stars formed our solar system, how the planets influenced each other's formation, how we're all made of stardust.
Yeah, it's pretty amazing to think about. It's like this cosmic web connecting everything together.
It really makes you appreciate the delicate balance of the universe, and how everything is, in a way, related.
And it makes you realize how much we still have to learn. I mean, we've come a long way in our understanding of the universe, but we're really just scratching the surface.
Exactly. There are still so many unanswered questions, so many mysteries to solve.
But that's the beauty of it, right? The journey of discovery never ends.
Well, to our listener, I hope you enjoyed this deep dive into Professor Dungana's Chapter 7 planetary system as much as we did. It was truly a fascinating exploration of our solar system, from its fiery birth to its distant future.
And remember, if you have any burning questions about the universe, any cosmic curiosities that keep you up at night, just send them our way. We're always ready for a new deep dive.
Keep looking up at the stars and never stop exploring.